Hello, in this video, I want to show you how to create a Voronoi pattern. A Voronoi pattern, which is named after a Russian mathematician, Georgy Voronoi, is a geometric system that divides a space or a surface into regions based on the proximity to a set of given points. Each region, called a Voronoi cell, as you can see here in this image, um, consists of all points closest to a specific seed point. So if you have like a population of seed points like this, as you see in this image, then each cell consists of all points in it that are closest to a specific seed point. This pattern is widely found in nature, such as in the honeycombs, leaf veins, cell structures, and cracked earth, making it a biomimetic tool for computational design. In architectural design, Voronoi patterns are extensively used for their organic aesthetic, structural behavior, and adaptability. And I can say mostly it's because more attractive. One of the key applications of Voronoi pattern is in facade and screens, that they can create like a dynamic perforation. And then you'll see that designers start to optimize the pattern regarding lighting, shading, and ventilation. Um, Today I want to just show you how you can create this pattern using Grasshopper. When you want to get started, so these are like different models that we want to create. We'll get started with a very simple 2D pattern. So I'm going to just turn this off. And we'll get started with creating our initial population of points. So I would say, okay, I have a rectangle in XY plane. And this rectangle has a size of, for example, 10 to 50. There we go. Now I want to draw a population of points. Under the vector menu, there's a palette it is called grid. And there are two options. One is populate 2D and the other one is populate 3D, but basically each of which provides you a random population of points. Since we're going to work on a 2D pattern, I draw a 2D population of points here. And I say, this is the region, and I want a number of points, for example, between 20 to 100. So this is it. I can increase or decrease the number of points. And the next step is that you can use the Voronoi components available under the triangulation palette under the mesh menu. Here it is, the Voronoi, which provides you a 2D Voronoi pattern. So you just use the component of a point and then also the boundary. So I'm going to connect this rectangular as the boundary. And here you can see that this pattern is created. You can also give radius value. And this radius value would kind of fill it that kind of pattern. So if you fill it the cells too much, you will just have randoms, a random population of circles. But if you like increase it gradually, you will see that at some point you will get more um, um, curves here, and then you can try a kind of like bubbly shape pattern. Now, away from this, you can also create like a surface pattern. So you can just simply get those points and scale them, scale those cells. You can call polygon center. And here are the polylines. Just gonna turn this off. As you see that the polyline center is quite different from those random populations. And that's basically because the definition of those points are different. So I would say, okay, get the center points, and then I can scale that pattern. Oh, I need to keep that. All right, and now the center point can be the average polyline vertices. Here it is. And I can give it a scale factor, which can be like between 0.1 to 0.9. This is it. This is too small. And then I can just say surface. There you go. If you want, you can call boundary surface and say, okay, here is the boundary. Let's just get rid of this. And you can, you can get that. And so this is an internal boundary. Now I can also give the outer boundary and provide this kind of two-dimensional perforated pattern through a Voronoi shape. The other pattern that you can create is kind of mapping this Voronoi pattern on a curved surface. Let's do this. So in the previous videos, I demonstrated how you can create a semi-spherical dome. So this is the surface. I just created a sphere and split it by using isotrim component. And now I have this surface, and I want to this vector draw a population of points on the surface. The component populate geometry let you draw as many points as you want on that surface. So here it is. And then now the next component that you need is the component facet dome under triangulation. This facet dome actually creates a tessellated pattern using Voronoi shape. So I will say, okay, this is the population of points. And here, since we have a curved surface, a three-dimensional form, instead of the boundary, it asks for the box. So I call the bounding box component and say, okay, here's the bounding box. And this is the box. I will turn this preview off. Now you can see that this Voronoi pattern is mapped onto this surface, which is nice. Right, now let's do that same thing and kind of create a surface. So I would say this is the geometry and poly Well, this is a dome surface. I would just take the population points as the set. And here is the factor between 11 to 9. Here is the scaled boundary surface. So this is one geometry, and then the other one is this. Now I have this surface. Now, if I want to create a sort of extruded element, I can extrude this surface. The base. And now I need the direction. Since these surfaces are tangent to the surface of the dome, I should, I can just extrude them along the z coordinate. So again, as we discussed in the previous videos, we're going to call amplitude component. And this amplitude asks for a vector, which is, I say, 2-point vector, 2-point vector. So this is the vector. And 1 point can be basically these population points. And then the other point can be the center point of the dome. So I would say 0, 0, 0. This is it. And now I should also define an amplitude, which is, I mean, the magnitude of that extrusion. Okay, so now you can create a sort of extruded form. So this is the next Voronoi pattern that you can create. I will demonstrate the other two in the next video.